Alright guys, as you may notice, the chiller here behind me in the middle, that's the one I just replaced the last 3 compressors on and the EXV. I'm not going to go through the installation of the compressors, but I am going to show you how I did the filter dryer, how I changed the EXV and put a ball valve in there. So if you guys are interested in that, and then we're going to do the startup on the compressors, kind of just showing what I did on that. You guys check that out. I'm going home. I'm out of here.
This video is brought to you in part by TruTech Tools, quality tools, essential support.
So we're back at this site here where all these things are just Jim Dandy. We're back, and what I'm gonna do, I'm gonna show you what I did on the filter dryer, how I did that part, because I already got the new compressors in, so no sense of showing you something I've already did once. Because like I said, this thing's 6 total compressors, and I didn't show doing the filter dryer part, so we're gonna do that. We've got to make a bracket for this to be mounted. I already went over there and kind of found my spot. What we're doing today is getting this filter dryer canister cut out because it's not adequate. Not for the kind of gunk we got growing in this thing. We're also changing this EXV. Also, one of the viewers or two said that we should probably put a ball valve in there. So we've got a Copeland ball valve, which will make it much easier. Oh, does this even got a, oh sweet! Has a pressure port on it. Look at that. Sweet. So that's going to work out beautiful. Thanks, Dina. Copeland's right down in Sydney, Ohio, which is real close to me. It's only about 45 minutes away from our area. That's why I said we should the carrier should be using Copeland, not this Danfoss French. Also, same thing. This time I went ahead and went 40-45% silver on this thing. Still had some leaks. Had to go back over top of this one. It still didn't want to take worth a crap. I fluxed it, sanded it, got it all prepped. The regular brazing, you know, here turned out fine. No leaks on that. The suction surprisingly held okay. We're basically adapting this so that we can fit the new 969G in here. Like I said, shouldn't even have to do this. This should have been built right to begin with. Engineering sucks. This here, hopefully. Nope, they just give you a generic plug. They needed to give you a nice Schrader port. So unfortunately, we're gonna have to use the one from the factory there. As you can see right there, that black nasty death there is not a good thing. Definitely not a good thing. So what we'll do is we're gonna move this down a ways. We'll mount that across there. We'll bolt it back down into there. And we'll use these two bolts from this to bolt that down. We're gonna saw this sucker here off and then slide it off. The problem I ran into last time, I couldn't get it to slide off. I did not want to braze it out with it connected because there is oil in there. So we don't want that. Potentially could cause a flame flare up with a braze torch, so that's really bad. Unfortunately, what I had to do the last time, I had to use my bandsaw and cut that because it was just a freaking mess. Because it's gonna fall straight down anyway, and we're gonna throw this away or actually use it for something else. Maybe, I don't know, I threw it away myself. There we go. There's the nasty drip of death. There we go. Oh yeah. This is absolutely horrible. Okay, you ready to see this goodness? Looking good in the hood. Now see where all the nasty stuff is going to be over here on this one. Last time what I ended up doing, I just cut that sucker. Horribly bad, horribly bad. All right, so we're just gonna clean this up a little bit. That way there's no sharp edges. Wouldn't want a helpless engineer to get cut. So they can take that apart and analyze it. Honestly, this isn't their issue. This is a issue with the firmware. I tried to make it so I could pull it apart. I would have just heated it up and pulled it apart, but the problem was there's potentially and very likely is oil in that area, especially with the way it kind of pockets. And and then you potentially have a flare up and a big old fireball, and I'm not dealing with that. I mean, the UK, we're good friends with them about now. So that's what it looks like on the inside there. And on that side there, not a whole lot to it. And your control connects here. I do got 15% and I have 40%. This one right here is 15. We probably may have to cut this more. This one didn't have a bunch of oil in it like we did the last time. I do have my safety shields on there, see? I think I'm gonna get actual safety rated glasses the next time. I mean, these technically probably kind of are because they're polycarbonate. Yeah, you wonder why that probably didn't slide off very easy. Yeah. Not sliding on or off very easily. That's deburred, yet it doesn't want to come off with a squat. But yeah, that's not very friendly, so we'll get a grinder wheel. Get some of these on Amazon. We'll try to do it away from blowing it into the unit. Filter her out, get it on the next go around if it has to. So it still don't fit with a crap. So that goes to show you your tolerance. Since it's made in Mexico, maybe they got metric pipe down there, but you can see we don't have anything screwed up, and this still don't fit on there with a crap. So we got it nice and plugged. So we want to make this nice and close. Get about an inch into each of them. That way you can get some heat on either side of it. It's not such a big deal. So get it pulled in. Look at that, American-made copper. And we want this fitting, pressure fitting on the other side. There we go. Got a little bit of a gap in between there so we can get the heat in there. It's a little more than I wanted, but it'll work. They've already cleaned that out as good as you're going to get it. Now we can work that on here with this longer piece, basically stretching it out so that it fits on there. Perfectly clean. See down to the center of it? There we go. That'll match up perfectly with that hole, and we'll drill a new hole here, and we'll run them bolts right down in there, and she'll eat right into it. I think this here, we had to take these off. There we go. Not the greatest. I mean, I don't have full use of all my hands down here, so kind of got to just do what I can do. There we go. And oh, that's great. When it fell, it bent it. That's great. There is nothing better than that happening. I love it when that happens. TruTech Tools is one of the few places that sells all the individual heads. So had a, it only comes with like a 7/8 or something. So we'll should be able to stick that right in there and straighten that right out. There we go, just like new again. Look at that. Just like a glove, it should drive it right in that hole. Another hole, it should line up if they did their job right, which I doubt they did, but we'll see. Get the right angle stuff here. There we go, and that leaves enough room here for this other filter dryer, because that is something I took into consideration, because God knows when you're engineering something you probably wouldn't, like that. And hook a pipe in between it, and we're good. Burn, 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 get her done, done, done. Like I said, the only reason why I do this is so that it'll hopefully flow quicker and easier. Normally I don't get too extreme about it, but I'm going to get on sensitive components here, like the ball valve and stuff like that, and I don't want to be on any of it any hotter and longer than I need to be. On bigger stuff like this, a lot of times it just takes longer to heat it up. Just like those compressors over there, they took a while to get done. A lot of times people don't understand when they're scheduling you that this ain't a 5-minute job. And if you screw up and you have leaks, you now have lost hundreds of pounds of refrigerant, 100 pounds of refrigerant. That's a lot of money gone. Thumbed the first knuckle, which put me about right there at that one. Tape measures are overrated. So like I said, what I use are these towels here that we've got that are kind of heavy duty. So it's just going to give you a nice long wet deal there to kind of pull out, fill it up with some water, and do our thing. Those are just Frisch's, I think it is. Fiskars. I don't know, they're pretty badass. A week ago, we changed 3 of these pumps that were provided. They're still overheating. We did those on 6/17. Today is 7/8, all 2026. So they were provided for us, but then they wanted us to wire them directly around the relays and all that stuff here. But they still got issues, and then when you know it, we haven't had any problems. And we built that tank there, our welders did. We lost a motor over here somewhere, one of these. If we hadn't lost any of these, we thought maybe it was an issue with back pressure from the pump, whatever. But yeah, like I said, it kind of goes throughout the different parts of the factory. And then here's some of the air handlers for it. That's how they're ducking it in. And over here is some water. And there's another air handler. Kind of a little recap. See how I had the pressure port? Well, there you go. Ensure the valve is fully open position before brazing. See figure 2A. Failure to do so could damage the internal components. You explain to me why that is in that position. That's not sure. So they want you to max 120 Celsius. I'd have to figure that out. Probably about 230-ish, 40-ish. Okay, I've got a couple different philosophies here on brazing this as far as direction of flow and stuff. One thought process is we blow that direction so that we push the oil away from it. I don't want to deal with oil in my fittings, which the heat will pull the oil just like it'll pull water and everything else. So I got to put this on there, and then we'll take out the filter dryer and stuff after we get everything kind of brazed in. Leave a thread or 2 off on that so that you don't get that into the filter dryer. You don't want to tighten that up before you tighten up those bolts on the bottom, so I only tighten up the 1. Okay, we got that up there, so we're going to purge nitrogen through here, through the plate heat exchanger, up through the suction, and out through there, and it's ball valved off there. Once we get done with that, we'll bleed backwards this direction, then we'll just let it leak out through the fittings there. You can see the crap coming out. Like I showed on that last video a while back at that school, we ended up just hitting it with regular 6%, and this go around we're going to do 15, see if it flows any better. I'm going to put a little bit of flux on the outside. I'm not really worried about it too much. I just, for the most part, I don't usually use it, but you know what? It didn't flow real great the last time. I don't know. That's why we're going to try the 15%. I always like to kind of go underneath of it. You know, we want to pull into that pocket there, the socket, as I always call it. See how nice and easy that flops around. I heat this piece up here mainly first, and we're going to try to get it to come into that. They want you to come in through the bottom. I like to make sure my flux is attaching itself first. Now we'll bring it into it. Big thing is put your heat on this before you put it onto that stainless steel. And you know, you can't really get in here good and easy. Hopefully it got in there, I don't know. We're gonna double check it and see how it did. You gotta make sure that you're not overheating the valve itself, which we're cold to the touch on this body. Not cold, not hot at all. Looks like we got around on the edges there. Whether it pulled as far as I wanted it, I don't know. But either way, you know, we got it. You get too close to it and it'll actually screw you because it won't get hot enough to actually melt. That's why I'm kind of more or less wrapping most of it here on this side. All right, good deal. So we're going to start here with this one here. We're going to go ahead and use 15% for pretty much everything. See, that cold water is making that not want to melt. It's screwing me. But it's still melting the paint anyway. So you're better off just go ahead, hit the shit hard. Look, already getting cold, hot. Already getting hot. You're gonna burn the paint a little bit. Oh well, boo-hoo. Let's get this son of a gun melted in and move on. Because that's why I don't like wrapping some stuff with braze rot or with freaking wet rags. Because a lot of times what ends up happening is it bites you and ends up causing more time, more heat being put on the piece of project. You would have just went ahead and heated it up running hot, get it done, get it done. But looks like I got it. That. All right, it's good. We'll cool this baby down because I really didn't want to get it that hot, but didn't have a lot of options there. Ain't the right thing to do, but guess what? I'm not gonna have that valve take a crap because of it. I ran deep into the pocket as I could. I mean, it's at least halfway in there. Sure, in a perfect world, we're gonna go all the way to the back, but I got in there about as good as we can. Now, I'll clean that up just like I did that part right there, and it'll look fairly good. So here we go. Here's the finished product before we paint anything. You see we got all the way around it. Got pretty good fill all the way in. Same thing with down here. I mean, we got it cleaned up as good as it could. A lot of that is because you're cooling it down with rags, and that kills it. See how this one here is more normal and uniformed all the way down to here? I mean, that wet rag thing will kill you, but the alternative is you overheat stuff, so you ain't got a lot of options. So here's what we ran the last time. We're using the RC4864HH for wax removal and cleanup after hermetic burnout. There we go. So there's that, and all this this happiness. Didn't hurt anything leaving it in there, and I went ahead and bled right through it. Okay, it's got a nice screen there that helps catch the microparticles. The newer ones have a pull tab, which makes it a lot easier. Still need to make sure all that loose particle crap comes out. Never tried this before, but it works, I see. Just using my valve core removal tool built into my Klein to remove this. Ouch, son of a mother goat. That worked out really well. I've never done that before. You seen that first here? Look at that little clock spring. So that goes right like that. This goes over top of it like that. Works out perfect, see? I like it. I don't know if they don't show it in the thing, but that's how I'm doing it. You do what you want. That goes like that, and this goes like this, and look at that, Jim Dandy. There you go, nice and tight. Good and tight. It's kind of a German word right there, good and tight. There you go. And that holds it behind it. And this here, like I said, they never tighten that up, so it'll be fine. She's slowly coming down. She's 2600. I had one little leak there on top when I was purging that nitrogen through. It looked like it blew a bubble. It just wasn't coming down at all. And we'll get this thing hopefully running and let it run overnight, and then we can change these tomorrow. You can see we're starting to turn green there. Okay, we got our vacuum down. Add a little bit of refrigerant here. Yep, 600 amps, 2500 amp panel, not bad. Let's go ahead and turn on this suction here. This didn't want to cooperate wonderfully well yesterday. There we go. And then they got these little wonderful stainless steel things in there so you don't accidentally turn it or something. Let's go ahead and plug this in. Good. We'll put wire ties on that here in a little bit. I can hear the EXV chattering away down there. Let's check these compressors, make sure they're not shorted to ground from the factory. That would be my luck. .47, .47, .47 to ground. Thinks there's voltage here for some reason. That's all on. Let's finish up this. Finish opening this up. There we go. Local on. Make sure we got pumps running. They're all running. Something's speeding up. That don't sound good. Okay, we shut this one down. This one is 100% on circuit A, and we're at 66% on circuit B. So nothing's blowing up. Hopefully it will bring on that third compressor here in a minute. Turn off a black, nothing there. 50, 50.5, 50.51, 51. Shouldn't be nothing on this one. There's not. This one here, this is A circuit, 51.3. This one here, we are 51.2. We're good there. Grand total amps on one leg, 210 amps so far. 220 on that one, and hard to get that one to go. So going bottom lugs, we are 479, 482, 481. Going across it, nothing, nothing, nothing. We could go and drop it down like I did on the last video to a lower number. That way we can see if we can get into the millivolts or whatever I was at, but that one obviously is open. That one's nothing. Not a great way, so to speak, to know whether or not, but at least gives us a clear indication. If it is, you know you've got yourself a freaking issue. Most likely Friday we will come and check the acid level, or Monday. Because like I said, I want to do 2 changes before we even waste time checking acid. Oil levels. What you've got is the leftover crappy oil in the condenser. The third one finally came on. You can see they're all sweating. See the oil right there in the bottom sight glass, Somebody put a freaking wire right in the way. Very top. So kind of dark. See how it looks like over here on this other one, because it was just as bad. Yeah, still dark. This one must not be running. It's at the lower end. Looks dark, so it's probably going to stay nasty and dark. Don't matter what color, I guess, as long as it's got the viscosity that it needs. So let's check that amp draw on that one real quick. 50.1, ooh, 55, 52. That's how these look. 55, 52. So it must be the way they are. All right. That's usually unbalanced voltage a little bit. A little more voltage, a little more amps, a little less, a little more, a little this, a little that. Okay, well, what we're gonna do, we're gonna go to that chiller that I turned off. We're gonna crank it up to maybe 43 degrees. That way it can kick on in case this one fails out. So, because our set point's 40 and we are coming in at 50 and leaving at 30. So it's kind of a little bit on the juicy side there. All the run times have been zeroed when they did all the firmwares. Probably won't be able to change set point until I log in, which kind of sucks. That means I got to scan it out here in the bright sun. Service, go into my program here, Carrier Smart, sign in, sign in, sign in, there we go. So we scan that barcode, hit the lock button, got it. Here's my new password, hit it. Okay, we got it set for 43 degrees. Back out of there, go home button. Home button set for 44. It's coming in at 50, leaving at 49. So that's gonna help bring everything down to temperature and let the other ones coast. So it thinks it's 49. Let's see what the other one thinks it is. It says 40 and 49, so 40, it's set at 38 and 46. So it actually sees colder water than what the other ones do. And I talked to one of our guys and they said, yeah, we're shooting to try to get all these motors changed out. Supposedly they can handle 200 degrees, but the grease ain't handling it very well. But we're gonna see if we can't get them all switched to bow door or something like that. That's to number 2. This here's to number 1, and then the middle one's a backup pump. They got check valves built into them, so they both can be open. So if this tries to go up, tries to go down, it'll stop on that check valve. That's what you got here. Basically, you've got a stop and a check valve built into both. You got pressure transducers here. It's reading back to the actual inverters. These inverters are outside rated. Problem with these are they tend to overheat, which is another joke. But yeah, we ain't gonna get into that. But yeah, that's what we got. And then that just does the cold side going to the chillers. Over here, this is going out to the plant. So same thing, backups on each one of them. 3 sets of air handlers is what it appears to me. I haven't walked the whole building to see it. We've got other chillers on the other side. They're just a little bit smaller. But these are all running 14, 13, and 34 PSI. So everything's up and going. We should be good to take off. And that's what we got. So everything should be good to go. Everything's set up and it's running. We've got it staged to the point where it should shut off on its own and let this one do most of the running. That way I can get more run hours out of it. Hope you guys enjoyed the video. It's kind of a continuance, but at the same time, it's just how I brazed it in, how I used nitrogen, how I made it work, and kind of went from there with it. So I appreciate you guys watching the videos, I really do. If you haven't subscribed yet, please consider doing so. You know, that's the whole reason. If I can hit 100,000, I'm going to quit. So help me hit 100,000 so I can retire off of this. You know, good life. I'll be living in the Bahamas somewhere off all that money I make off of YouTube. Said no one. So other than that, I will catch you guys on the next one. Say later. Oh, hey, don't forget to tell your grandma about it. Later.